Alright, so let's get started. This is going to be engineering management. I think this is like the 8th week or something, or the 7th week or something. Can you guys hear me in the back? Here we go. That sounds better, but I don't know how to get this positioned so it looks good. Here, we'll play with this thing. Alright, there we go. Alright, so what I'm going to go over today is software engineering and the software development lifecycle models. And what I've got, what you're looking in front of right now is called the midterm. Yes, we have a midterm in this course, and the midterm is a software engineering, software development lifecycle model exercise, which is why we're going over that topic area today. So this one is in the EMS, and you can see it. Actually, in order to submit this, you'll have to go into the exam section on the left-hand side of the EMS. It moved over. I've already had students telling me, oh, I can't find the midterm. Where do we submit it? Well, you submit it not in the same area as the assignments. You submit it over on the left under exams. So look for it. You'll have to be a little, exploratory up there. Go in there, explore the system, find the exam section. This is your midterm exam. It's a take-home exam. It's due on the end of the course, which is what, December 16th or something like that. But considering that this is the midterm in the point, it's not a bad idea to start working on it if you haven't started working on it already. All right, so let me go over it, and then I will go into the lecture today. And the lecture today is going to be on the same topic. All right, so complete the following exercise. And your total assignment should be 3 to 4 pages in length, double-spaced. So what does that mean? Well, what do you have to do? Here's your topic summary. You're going to implement a new software hardware system, and knowing that it can be quite a challenge. So you're going to take a methodology approach to this. So you're going to imagine that you work for a company and that it has a traditional style human resource department, and that it does not offer any services via the internet. And so the company decides to create an employee self-service system, and this is going to use the internet technologies to deliver HR services to employees. And so you're going to write an analysis of the steps that you take to solve the problem and create this new system. Think about system analysis and design concepts. I'm going to go over those today, as well as any software development methodologies and practices you might be familiar with already. But don't worry if you're not. You could take a couple of different approaches on this. So you can be creative in your analysis and in your response. So system requirements, specific requirements, so of the midterm, I should say. This is a project plan and analysis proposal paper. Do not write source code or provide an implementation or prototype for this. You're not creating the system. You're an engineering management person. You're an engineering manager. You're planning the system for its implementation. So don't make the system. And believe it or not, I've had students actually do it. And I'm like, I don't want a website here. I mean, I don't want you to turn in a coded HTML website with JavaScript or jQuery or whatever it is you like to use. No, you're writing a report. It's a proposal. You're going to plan out the development process. So you're planning the system. It's a business activity, not a software engineering activity. All right. So describe how you would formulate your team, assuming that you're starting from scratch and sky's the limit, and you're able to... kind of hard to carry. So you're able to formulate your team, and you're in charge of hiring your team members, and you're going to, essentially accomplish that task. What type of people would you include? And when would you bring them on into the project? Imagine, or try to make this as real life as possible. I went to one of you and I say, hey, we need a employee self-service website utility. I'd like you to put it together. So what do you do? Well, you're probably going to need a web developer, or maybe you're going to contract it out. You're probably going to need to use a methodology of some sort to develop this, and that's what I'm going to talk about today, actually. So what steps would you take in the analysis and the design of the system? How do you even know what features you want? So don't come and ask me, oh, what feature should I put in here? That's what you're doing. That's what this project is all about. Don't ask me what features it needs or how long it needs to be. I don't know how long your write-up is going to be, seriously. You want to make it at least 3 to 4 pages in length. You can make it longer if you want. You could put diagrams in there, charts, project plans. You can do project planning if you want, as well as software development lifecycle planning. That's also a possibility that you may also want to include. What steps would you take in the analysis? What are the major components that will be included in the system? What features will you do? What timeline and processes will you use to complete this project? A simple project plan is needed to figure out what order the steps should be taken in, and what sub-steps will be involved in the project. What milestones, checkpoints in the project plan. You do not need to use Microsoft Project or develop a real project plan. In fact, your project plan or your steps could be like 5 things. Hire the people, get the resources for the technology or something like that. I don't know. Implement it, test it. It could be very broad. It could be very general. How long will it take for the project to complete? What will it cost? Be realistic, but of course, accuracy is not part of the grade. You can make up the cost if you want, or you could cost it out. So if I went to you and I said, hey, and we need this employee self-service program, how long is it going to take and what is it going to cost? So we can put it in the budget. So how would you cost it? That's an interesting point. And how long is it going to take? Well, you don't know until you actually divide the work out. You're not going to do it yourself. You're going to have a team do it because you're the engineering manager and you're trying to use your team. Your project proposal should be convincing, inclusive of all information and steps, as well as descriptive for exactly what you're going to build. And make sure that the project proposal is on the HR theme described above. So fill in any missing details that you might need in order to complete this project. Do not pick a different theme. It must be on an HR department employee self-service system. And then some people generally ask me, well, what's an employee self-service system? It's so you don't have to go into the HR department to ask a question. You go to the website and you fill out forms for requesting vacation or time off or reporting a problem or getting a performance review or giving a performance review. Or imagine almost everybody in the room, I hope, has been an employee at one point. So if not, go online and Google employment and HR, human resources. You don't have to be a human resources expert. You can come up with your own features, but that's the theme. You're writing an and it's a self-service system because it's going to run on the internet and using any technologies that you want, actually. And it's going to provide services, a self-service, so the employee can go in and get things that the employee needs, like apply for jobs, or check on the status of something, or contact their manager, or report a problem. So there's not that many features in it. I tried to pick something that was on the small side. It's a pretty small kind of system to put into place. It shouldn't be too difficult. What I want you to do, though, is to go through the process of planning the solution. Questions on what you're doing for the midterm, not on the content yet, but on the concept of the midterm. Any format that you want, any style that you want. You don't have to cite references because you won't have any. You're making this stuff up. You're not using stuff you're finding on the internet. Do not use anything that you find on the internet, including images, charts, pictures, tables, price quotes, or anything. Don't even open up the internet. Use a computer that's not connected to the internet when you do this assignment. I'm not expecting you to research anything about this at all. Now, do we have any questions? Not a hard assignment, actually. All right, so this assignment, the midterm, is based on lecture number 9. So this is Management of Information Technology. If you go into the website and you look in the management, this is the, yes, this is the Technology Management Lectures. It is number 9. You're going to want to remember this because this is what you're going to use as the textbook. This is where you're going to find all the information you need to complete the midterm exam. So everything is included in here. You don't have to go out and research methodologies or anything like that. As I mentioned before, you could do this entire assignment with a closed internet connection and probably do much better than if you had internet activity. So I highly recommend going offline when doing this assignment. All right, Systems Development, lecture number 9. Phases, tools, and techniques. What are we looking at today? Today we're talking about software development lifecycle models. Software engineers know all about this. Engineering managers, some of them do, some of them don't. If you're from a business background, you probably have never even heard the word before. It's an SDLC. Stands for a software development life cycle. Not to be confused with project management, not project management. But we need project managers in the world. Project managers make our project run smoothly and allocate resources correctly and time. But we're looking at today the concept of developing software systems. Your HR system is themed in the midterm. So most of the traditional development lifecycle models started out with the Department of Defense in the beginning. It was called the waterfall model. That model came up with 7 steps. They called it, well, it really is called the traditional system. So there's 7 major steps to it. Actually, you could probably make 5 major steps to it. Your accuracy in terms of your software development lifecycle model selection, what you call it, how many steps you give it, is completely up to you. Because in reality, people came up with these models starting out with the waterfall model. And then over the years, people adapted new models and new techniques. And then people have combined different techniques and different models and then rechanged models. So the concept of the model is not what I would call a hard science. It's sort of a soft science. And what I mean by that is that there's no right or wrong model. There's no real methodology to this. It's the practice, or it's the concept of separating out the work into steps and then performing the steps iteratively or in a cycle or in a flow, like from one step to another. So I'm going to go over the concepts, and then we'll see and compare and contrast the various different components, and then describe the self-sourcing, outsourcing, and insourcing kind of options you might want to take. In your midterm, or for the HR theme, you can outsource it if you want. You still got to write a proposal, you still got to complete the project, but all the implementation could be completely outsourced if you wanted to. Why build it? I mean, you know, you don't really have to these days. You can get HR systems outsourced all over the place. So, discussing the importance of prototyping as well, we'll get into that, as well as describing outsourcing environment and how outsourcing works, just in case you want to take that option. You may not. I mean, you know, it's totally up to you. I don't know if I would outsource it. If I had the people on hand, you know, and when I was describing my workforce, I'd say, hey, I got a very experienced software developer who's got, you know, 9 years of HTML experience. I might have them do it. It might be cheaper than outsourcing it. Outsourcing is generally going to come up with a more expensive option in the end. So, saving lives through system development. All right, I'm not going to go through this Center for Disease Control example, but the book that this comes from has an interesting couple of case studies in the beginning where the wrong implementation of the wrong model led to some problems, and then the implementation of the right model saved lives, essentially, by creating an organized system to report diseases and report activity. The big thing to get out of it, if you do have this book, is, you know, you probably don't know, nobody in here probably does have this. If you do read through these case studies, actually one of the important themes that comes out of software development lifecycle models is that you can't really tell unless you benchmark something if the model is working. But do you really want to take a risk of not using a model? And then if you don't use the model, the chances of the software actually being successful and things actually working out are kind of slim. So we're still on. Okay, good. All right, so the support of the structure for meeting company strategies, new goals, creating employees' requests from them. New systems are created by attaining competitive advantage. All right, here we go. When developing new systems, we have 3 choices to choose from. So at the beginning of the project, you might want to decide, after you do a little analysis of your resources that you have available to you, and then you got to make all that stuff up. In the real world, you don't have to make it up. You actually have those resources. You can say, well, I've got this and this and this. But let's say I'm a retail store and I'm putting in the HR self-service. You could pick a model company if you want. Actually, that would work as well. Pick a company, maybe one that you work for, maybe, and just say, hey, we don't have this at my company, or maybe you do. What you don't want to do is reverse engineer, because then you end up going the wrong track, usually. So. But when developing a new system, you got to come up with a couple options here. Insourcing. So most people have heard of outsourcing. Let me give you the other 2. Insourcing. So IT specialists inside your organization. You're going to build it yourself. You're insourcing it. Or you're self-sourcing it. You're seriously going to build it yourself. You're not going to have somebody else inside the company do it. You're going to do it. A lot of engineering managers end up self-sourcing the ones with technical backgrounds, and then they realize, I'm not doing management work anymore, I'm doing development work, and we need to hire a manager now. So they're no longer really doing their job. So you get some problems with self-sourcing. End users taking with little or no help from IT specialists and doing it themselves. Sometimes it brings you down the wrong path, and then you're being taken away, and your staff is being taken away from what they're supposed to be doing, and then they're doing software development tasks that maybe they're not even qualified for. Insourcing is finding the IT people and finding the specialists within the organization, having them if you have them. So at the beginning, if you define your development team, you actually have a developer, then I'd insource it, really. And then outsourcing it, we all know about that one, having a third-party company, let someone do the work and then pay them for it outside of the company. So insourcing in the software development lifecycle model and how that works. So insourcing is using the software development lifecycle model. Actually, the model can be used with all three components. Most popular, it should be used at all times with insourcing. Doesn't necessarily need to be used with self-sourcing because you're the development team and you're the developer. You're managing yourself. There's nothing really much to manage. Outsourcing, this is the classic mistake a lot of companies make, and they end up not getting what they want because they didn't do a software development lifecycle model. They left it out because they figured, oh, we'll just outsource that. All right, so let's see. System development lifecycle model. By definition, it's a structured step-by-step approach for developing information systems and software. Well, it says information systems. It's everything. Software development, information systems, information technology projects, everything falls into that category. In the waterfall model, that's where we have the 7 distinct phases that are well-defined activities. We don't necessarily have 7 in all models. This is just characteristic of the waterfall model. The slide is a little deceiving because it lists it as a separate bullet point. It says that there are 7 distinct phases. Well, I only use 5, really. I don't even use 7 in my model descriptions. So don't take that number as a hard science. Also called a waterfall methodology. It's a waterfall. Actually, I call it a waterfall methodology, and we'll see in a few minutes because everything just goes downhill. Falls into the toilet. Starts good and it just goes downhill into the toilet, you know, which is basically a negative. So, and I'm not saying that it is a negative. I'm just saying there's some problems with the model. Not the best to be used these days, but some people still use it, and it's the easiest model to understand. So we'll start out by looking at this one. It's an approach in which each phase of the software development life cycle is followed by another from planning through implementation. Here's a list of the phases and major activities. So take these 7 phases here as an example. I was trying to get them all on the same page. Here we go. Get them all together. Planning, analysis, design, development, testing, implementation, and maintenance. Now in the waterfall model, the 7 stages are done sequentially, one right after the other. The way you differentiate all these models is the order in which the steps are performed, and how the model is actually organizing the pattern of the steps and defining the steps. So you could have these 7 steps. You could break them down into 5. I actually put more up here. Instead of planning, I put this feasibility study. Because if you're not going to do a feasibility study before you actually start the project, kind of hard to determine whether or not I mean, why would you continue if it's not even feasible? Of course, if you do a feasibility study on your midterm and you decide it's not worth it, and in a paragraph later, then you later decide, hey, we're going to can this project, that's not going to fulfill the requirements of the midterm. So assuming for the midterm purposes that the software can be implemented and you've done your feasibility study and someone gave it to you and said, here, we're contracting you out, Acme Software Development, Inc. Make this project for me. All right, but sometimes in the real world, we're not going to do anything. The project's not going to work. Like, you know, we don't have the money for it, you know, or we don't have the people, or we don't have the resources. In the planning stages, you're defining the system that's going to be developed. You have to do that. So for the midterm, you're planning, you have to plan it. So set the project scope. So the first thing I would do is come up with a, you know, kind of a set of minimal requirements and say, hey, this HR system, I'm going to have employee requests for time off, employee evaluations, and I don't know, employee performance reviews. That sounds pretty good. And then develop a project plan, including tasks and resources and timeframes. This is where project management really comes into place, is at the beginning. And that's the planning to say, and this is where you're actually right from the get-go, from day one, you're going to determine how long it's going to take and what it's going to cost. Because you're going to divide out all the rest of the work for the rest of the project. Now, for the development of the system, for the system development lifecycle, you're adding in steps 2 through 7. So the first one is really the project management stage. Although project managers would say, hey, it goes through the life of the cycle. It does. You come up with a plan in stage 1. You follow the plan all the way to the end. You're doing the software development lifecycle model analysis, and you're including a brief project plan. You don't have to do 2 of the same. You don't have to do a full project management plan. You do not have to use Microsoft Project or actually perform project management, because you're not really going to do the project. You're doing the initial planning of the projects. So in your software development lifecycle model, you can describe what you're going to do in analysis, which would be the second kind of phase, if you were taking the waterfall approach. So in the waterfall approach for analysis, you're going to gather the business requirements for the system. There's an entire theory. If you take a software engineering course, there's an entire theory on doing analysis. Most analysis entails interviewing the end user, interviewing the management staff, and analyzing other systems on the market. There's a lot of pre-work that can be done to understand what it is you're building and what the users actually want. And then coming up with, in fact, sometimes in the analysis, you're coming up with your test plan, or your criteria for what you're going to implement later on. Then there's the design. Now the design, okay, so the analysis is usually done by the business people, or the stakeholders, or the end users. If you're doing an agile approach, the stakeholders are doing this for you. Your customer is actually giving you the analysis, or you're helping the customer do the analysis for the most part. Now, and I'll talk about Agile in a few minutes as well when I go through the different models. But let's talk about design for a second. Who's going to design a system? I'd like a software engineer to design that system. I take the analysis, give it to a developer, and say, hey, design this thing for me. Or a software designer, software architect would actually be a good person to do this. So this is not all performed by the same person. It's performed by the team. So these steps are divvied out to the team members. In the design, you're designing the technical architect requirement for support of the system and designing the system modules. You could have, if your system is pretty big, you could have a database architect, a systems architect. You could have a developer, software developer in there. You could have a lot of little people taking pictures, taking a stab at the design from their own design perspective. You could have a UI, UX developer in there doing the interface for it. And step number 4, that's just the development. That's the build of the system. You're building the system. That could be outsourced. So you get to step number 4 and you say, you know what, send it off, have them build it out there, and then bring it back in. This is building the technical architecture, building the database and the programs. And then step number 5 is testing. You can, unfortunately, a lot of people have their end users test, but that's really not good. You could have your end users test the system. You could have the development team. You can have the rest of the company test the system. You're writing the test conditions. You're performing the tests on the systems, and then you're implementing it, which means you're actually going to install it on the company network and put it in place. It can be written and developed and tested without actually being installed. But once you install it, you have to test it again, and you have to maintain it. So in the implementation, you're writing the detailed user documents. You're providing the training for the system as well. I'm training your people on how to use the system. And then for the maintenance, you're going to build maybe, for example, a help desk to support the system users, and then provide some environments to support system changes and stuff. Those are the textbook 7 steps of a waterfall model. This is why they call it the waterfall model. It looks like a waterfall. But you start at number 1 and you end up at 7. Doesn't that look like it goes downhill? Now, if they wrote this waterfall model in the opposite direction, so look, you got to the top, conquered the project, that'd be a little bit more positive. So I'm just joking. I actually think this is a good model. One problem with this model is that you don't see anything until here, step 6. So if this software project took 1 year to 2 years to develop, which most big projects do, you think your customer is going to be happy with you if you haven't shown them anything for 2 years? 1.5 years, 2 years. Hey, look, it's coming out soon. Maybe next year you'll see the prototype. What? You know, how come I can't see it today? So the problem with the model is a late deliverable of the actual system. So then people have changed the model around a little bit to get past that problem. Another problem with this model is that you go from 1 to 2 to 3 to 4. What happens if you discover something over here in the development? Oh, you know what? We left something out. It's hard to go backwards. You know, oh, we're done with the planning. You know what? You guys signed off on this. Here's the design. It's done. You know, we're all done with the design. We can't add anything to this. And then your whole project is going to fail at that point. So it's too vulnerable because you don't know. You're going to discover stuff down here that you didn't know up here, and you can't go back and change it. So then a lot of people build feedback into this. So you see the arrows going this way. Oh, no, I was going to say the next slide doesn't have the arrows going the opposite direction, but you could put the arrows up the opposite direction and have the arrows going up this way. I have another slide set that does that. And then you can see all the problems that are discovered as you're going downhill. Before you hit rock bottom, you're going to, hopefully get yourself back up, go back up to the previous stages before you can recover from what you may have gone astray. So, all right, so I gave you some of the activities. I'm going to kind of skim through this. This is your reading material, however. It's 60 slides, and it's lecture 9 for those people, MIT. It's the Information Technology Series, lecture 9, because I'm going to treat this sort of like a textbook. Rather than reading 60 slides to you, I'm just going to give you the big picture. In the planning, the focus is on what's called the critical success factors. You can identify right up front what is a successful critical success factor. Well, it's going to be a measurement of whether or not your project's going to make it or not. If you can get this, this, and this implemented, then it's good. These are the critical success factors. So you can identify that. So critical to the organizational success or critical to the project success, as this says here. So in the planning phase, you're creating the solid plan for developing. You have the 3 primary activities. Define the system. If you can't build it, make choices about how you're going to, what are those critical success factors, and then focusing on those in terms of the planning. So in planning, we have some typical problems that occur. And this occurs, all of these problems and all of these situations occur regardless of which model you selected. We've only seen the waterfall so far, so I'll relate things to that. The other models, you just take the 7 steps and you reorganize them. And then you get more models out of that. So we have ones that do a spiral, ones that do an iterative approach, ones that do prototyping approaches. I'll talk about prototyping in a few minutes. People have just experimented with all these different ways of putting those 7 or 5 or how many steps you identify together, and then just do them in a different order, do them in a different routine, and voila, you got another software development lifecycle model. Go ahead and publish a book, and you're ready to go. The big thing, though, however, is does it produce good results? The waterfall model produces good results. Even though it has some flaws in it, it does produce good results. Maybe not optimal for fast-changing environments, but it does produce good results. All right, so phase 1, setting the project scope. The scope clearly defines in a high-level system requirements of the system. What is the system going to do? And then what you want to try to do is avoid scope creep. Scope creep is not good. Creeping of anything is not good. Creeping means it's out of control. The reason why you're doing all this planning is you're trying to get a good grasp on what's going to happen here. So scope creep occurs when the scope of the project increases. So you started out building an HR system. Now all of a sudden it's turning into the company website. Oh, could you add this feature there to it? Can you add that feature to it as well? You know what? The recruitment department, they want job ads. And then all of a sudden the project will never finish. It won't finish because you'll never run out of requirements to implement. And the system you're building is not the system you set out to build. That's scope creep. The scope of the system just keeps evolving and changing, and it never really locks. Well, they call it, well, actually there's a feature creep, but they call it feature lock. lock the features, lock the version, and you say, oh, you know what, we can add that, but that's in the next version. Let's finish this version first. So it's kind of like when you go to your boss and you ask, you know, they gives you a bunch of stuff to do, and you are not done with that stuff yet, but they're giving you more stuff to do, and then more stuff to do, and it just never ends. That's what happens with the project. So then we have feature creep. Feature creep is different from scope creep, actually. Scope creep is when the project itself just increases and increases over and over again. It's like your work pile. You're never going to get through all that work. The scope of what you're doing is just gone out of control. The feature is when the program is turning into something it's not supposed to be. Now this is an automatic data mining application as well as an HR system. What? Because the features moved. So it occurs when developers add extra features that were not part of the initial requirements. And now you got feature creep. So creeping up of, now this thing slices and dices and mows the lawn. And it also does HR. You're like, well, why were we doing all that other stuff? And then sometimes all that other stuff turns into requests that the consumer or the end user wants more of. Which, you know, what are you building? Which is actually kind of funny because some social websites have turned into that now. It's like, is it a social website or is it a gaming site? Maybe it's a gaming site. And then you're thinking, well, okay, if it's not a gaming site, well, maybe it's a business connection site. No, we won't see that on business connection sites. But anyway, long story short, actually, LinkedIn, it was originally supposed to be a business connections. It's now turned into an HR system. I mean, people are using it to hire people now. And they go through and they use it as background information on candidates, which is ridiculous because it's not supposed to be that. It's a networking site. You're supposed to network among yourselves and meet people and stuff. You know, it's like the internet in general has turned into social media marketing frenzy. But it wasn't supposed to be a marketing outlet. It's supposed to be social media originally. So anyway, I'm glad LinkedIn hasn't turned into a social media site. I'm thankful for that because I hate social media sites. I don't frequent those, and I would hate, because I am on LinkedIn, but I would never be on there if I knew I was going to be subject to social media crap. So I don't want to hear about how many times someone went to the bathroom or how many times some kid kicked a soccer ball over and over again every 5 minutes of my life. I just don't care about that. So, you know, I have better things to do off the internet. So long story short, yeah, don't ask me to join a social media site. Project scope documents. Another product of the planning stage is writing a definition of the project scope, and it's no longer than a paragraph. This is not huge documentation. I put on there 3 to 4 pages. You can make it longer, but don't give me a 50-page report. It's just ridiculous. You know, in fact, I had one teacher when I was going to school tell me it's harder to write fewer words. And this guy would like take points off the more words you wrote because it means the words are garbage. It gets worse. So if he said make it a paragraph and you made it 2 paragraphs, you lost points on it. Because it's harder to put your thoughts in shorter number of words, more condensed, more precise, and you have to, it's harder in general. So you have to definitely be more clear. Unfortunately, nowadays, students take the opposite approach. They think volume is better. And then they cut and paste off the internet, so it doesn't really matter because they're not writing those words. And I look at it and go, okay, 50 pages of crap. Oh, okay, this came from that book. That came from that book over there. That comes off the internet. It's just, why bother? Seriously. It doesn't add to the quality of your assignment. All right, so develop a project plan, including a project plan, project manager, and project milestones. This is the project planning part of it that happens in planning, as I mentioned before. You don't have to do a quick project. You don't have, this is a project plan done in Microsoft Project. Actually, it's not. It is Microsoft Project. This is a task list with a Gantt chart. You don't have to do Gantt charts or critical path methods or anything like that. It's not a project management course. Take a stab, do some minimal project management, see what you can come up with. Next thing you're going to do is analyze the system. So once you get the planning stage underway, these are the people I have to work with. This is how long we're going to do it in. This is what we're going to accomplish. Here's the scope of the project. This is what we're going to build. Next step, analyze it. So it involves end users and specialists working together, understanding the document. So if I were doing my analysis on my HR system in this section, I'd say something like, I'm going to send all the users of this company a survey. I'm going to have them fill it out. What do you want to see online? What's the biggest problem? What is it the first thing you want to do when you go to the HR department? You know, and how okay. Analyze. This is analysis. You're getting not necessarily features, but you're getting the likes and the dislikes and what people would prefer to see in what order, maybe, or the organization or something. Now you can do that survey in the planning stages to elicit your requirements, and in the requirement stage, in the beginning, you could say, I'm in the analysis phase, I'm going to come up with the requirements, and I'm going to take it from the user surveys that we're going to do. So send a survey out, and everybody in the survey, which is the highest features? 1, 2, rank them, order in your, rank them in the order of your desire to see them on the new website or something. Now you don't have to write a survey for your midterm, but just say, hey, I'm going to send a survey out. And describe what you'd put on the survey. If you're going to do a survey, don't necessarily have to. Some people do prototyping at this stage. You get a web developer in there, build a prototype, and then in the same token, you're doing the analysis. You're coming out with, you know, a better understanding of the system. So analysis is nothing more than coming out with a better understanding, whether you do it through prototyping. You may not select that unless you're a software engineering type. Maybe observations, going out and watching people. Maybe you put a secret video camera in the HR department. People have done this actually. Put a camera in the HR department, not for confidential reasons, but you know, may not necessarily want to do it. Might not be legal. And then find out what the biggest complaints are for the people who walk in. I asked for that letter of recommendation 2 weeks ago. Where is it? You know, I don't know. Or, hey, my boss is really giving me a hard time. I thought you were going to take care of this for me. You know, and observe what they're doing, perhaps. In other types of system, people actually, like for banks and stuff, people actually go out and watch people. There's cameras next to the ATM, so sometimes I look at it and go, how long does the customer spend there? You know, oh, how long is the line at lunch? You know, or how long? And then, you know, they know what's going on, hopefully. Another thing you can do with analysis, and here's some other things, you can gather the business requirements from interviewing the managers in the department. So you're going to, you know, if I was building an HR system, I'd actually go and talk to the HR manager. Say, what is it that you do? And what's going on in this department? And what would you like to see online? You know, and then kind of just get some business requirements. So it's a detailed set of knowledge workers. You don't know anybody in the HR department? Then you could do a JAD session. You don't have an HR department yet. So it's JAD. It's Joint Application Development. You bring in a bunch of HR managers from 5 or 6 different companies. You sit them down at a table together and say, hey, what kind of challenges do you guys have in your department? You ask them questions. JAD people are generally coming from the outside, and they're coming from cross disciplines. If I were building a wireless technology product to work on an Android phone, I might bring in a wireless technology professional, an engineer. I might bring in a developer. I might even bring in someone from Google or something, or you know, something by Android related or something. Set a bunch of random people. They're not random. They're all working in different areas. Put them together and then see how they respond to certain questions that you're going to ask them. So knowledge workers, IT specialists meet, sometimes for several days. Define and review business requirements in the system itself. Actually, a lot of JAD sessions have stopped a lot of projects, which is good. You want to stop it as soon as possible. If it's in your analysis, it'll save you money. You don't want to build something that nobody wants, or you know, or build something that's impossible to build. You're going to do a heart monitor software, and there's a lot of other ones out on the market. You bring in a JAD team, and they say, don't do it. It's stupid. There's 5 different better ones on the market right now. You're doing something that's not as good as what they're doing. Then I take the money and put it on a different project. Stop this project and go to another project. So a lot of projects get canceled in the analysis phase. You can't cancel your midterm project, but just know in the real world, this is when it's going to happen if you're going to be smart about it. Just because you spend a lot of time hyping it, you know what, there's no shame in failure here, because this is going to save the company a ton of money if you stop it now versus another few more months down the road when you get into the design. Why spend all that money on something that's not going to work? So analysis is normally make or break. It's also prioritizing. You're going to prioritize the requirements as well. You're going to say, we're going to do it. These are the top 5 features we're going to put in. if we have the time, we'll do these other ones. Otherwise, the system's not going to work right unless we have these 5 of them in here. So prioritize it. And here's phase 2 of the analysis. So planning, analysis, design, and then this is pretty low in terms of the money. So over here on the left-hand side, we have money. So here it takes time during the analysis to get the business requirements correct. If you find errors, fix them immediately in the business analysis. And then the cost to fix an error earlier in the software development lifecycle is relatively small. At later stages, you're looking at, whoa. Over here in implementation, you're looking at the cost to fix the error, pretty bad. And so if you can't fix it, then that's the cost that the project is wasted. Down here, it's pretty minimal. So do it here. By the time you get out of design and it starts going uphill, your costs are going to increase. So now you're in design. You have a pretty solid product. You're sure that this thing is going to work. You've done your analysis. Now you're going to build a blueprint of this proposed system and how it's going to work. So you have 2 primary design activities. You're going to design the architectural design, technical architecture of it. You're like, okay, so the word architecture, I know some of you business people think it has something to do with building houses or something, or buildings, you know, models, homes and stuff. And then some of the software people, especially some at ITU, have never heard the word architecture before, because it hasn't been until recently that we've brought in software architects to do software architecture courses. There's an entire methodology to architecture. Architecture is like building a house. In fact, if you go back to the whole scenario, building a software package is just like building a house. You have architectural designs. You have a data architect who builds the data architecture. You have a software architect who builds the implementation in terms of the software part of it. Hardware architects. Here we're just going to call them technical architecture. All that stuff falls in technical architecture. Technical architecture defines the hardware, software, telecommunications equipment required for the system. Actually defines everything. And then we design the system models. That's the second part. What's a system model? Well, most people sitting in the room who are software engineers, they go, oh, you mean models? Modules? Or some people go, oh, you mean UML? If it's object-oriented, are we going to do attendance? Okay, if it's, let me stop at this stop. I just have to say one more sentence. If it's, this is the system model that you're going to use for the programming language and development environment you're going to work in. So if you're going to choose object orientation, it's going to be UML. If it's not, it's going to be systems analysis and design, or it's going to be another modeling approach to come up with the modules you're going to need. So, all right, break for attendance. All right, well, we're done with the attendance, so we're going to get back to the lecture so that we can get out of here at some decent time. And I have to get through the rest of software development lifecycle models, so here we go. So I was talking about design before we ended, and in the design phase there were 2 distinctive activities being performed, the technical architecture as well as the design of the system models. And as I mentioned before, this is the software development part of it, where the system models are the models of the software system in terms of the methodology being used for the development. So object orientation would use an object-oriented model, systems analysis design would use system models and other types of models that would fall into this category. So starting with the design, the engineering manager would take less of an active role and act more as a quality control function. So you're not doing all of this work, you're delegating it, and so your developers would be working in terms of designing the system. You as the manager would be overseeing what's going on and making sure that you're getting some good quality. And you might be wondering, well, how am I going to know if it's good quality? I'm an engineering manager, I'm not a software developer, how do I know what I'm doing? Well, then you get other developers on the team to cross-check everything. So it's really a team effort, long story short, to get everybody involved and on the same page, and everybody working towards the same goal, which is to produce something of good quality. So then, after you make it after the design being the stage 3, why is that still highlighted? Then you're going to go into the development stage. And in the development stage, you're simply going to build it. You're going to take all your detailed design documents, everything, transform it into the actual system. So there's two primary development activities that go on in the development phase, one of them being the build of the system, making it, implementing it. I shouldn't use the word implement because there's an implementation stage where you are implementing it. But this is the build, or the creation of the system. Also building the database and the programs that work with it. Both activities are mostly performed by IT specialists who are actually going to implement it, or into software professionals. So you can outsource the build. You can outsource the database design and well, not the design. Actually, you can outsource the design and the build. Usually the design and the build could be outsourced together by the same company, and then you get better synergy between the two products, the outcome of one and the development of the other, essentially. What you don't want to do is hire a company to design it and then another company to build it, unless you have to. Because what ends up happening is they're not going to like the design. Or sometimes when you design it and then you give it to another company to build it, you discover, well, that company doesn't like your design. So anyway, so that's why the design and the build normally happen by the same group of people, so that at least they're in consensus. So then you have testing. You get it back, it gets delivered, you know, it shows up in the mail, who knows. You take it, you test it. What are you testing for? You got a couple of different things you're testing it for. It verifies the system itself works. It meets the business requirements defined by the analysis phase. So you got verification and validation that comes out of this. So you're going to write two primary testing activities. One is to write and test the conditions. So we have test conditions that come out of it. So detailed steps of the system be performed along with expected results of each one of the systems. And then you're checking, well, the two components you're really checking for, is this a valid solution to the problem? And are we verifying that the features are implemented correctly? So we have two kind of perspectives to it. If you take a software testing course, you get into all of the different types of testing. You could do unit testing, integration testing, module testing, network testing. There's so many different types of testing strategies. For your project, you just outline, oh, we're going to do some testing. And then what kind of testing? Well, you don't have to get into that much detail. If you're a QA department, when you're working with testing, well, quality assurance doesn't actually do the testing, but long story short, you're usually getting contract work from, I don't know, college students. You give them a couple of, I don't know, things of pizza, and they test. And they're usually doing black box testing, where they're taking the completed feature and they're performing some activities on it to see if this works or that works and stuff. Versus doing like integration testing, where you're bringing this piece of the component in and you're testing it with an existing component on another system to make sure that the data communicates back and forth correctly and stuff. So performing the testing of the system, here's a little sampling of some of the general tests that you might want to pick for your HR department system. Unit testing, the individual units of the code, the modules of the code. If you have the design written out, you can do your test plan while the design is actually, well, while the development is actually going on. You can do system testing, verifying that the units of the code function correctly. Integration testing, verifying that the separate systems work together. And then user acceptance testing. That's kind of critical, actually. If the user doesn't accept it, well, that's kind of a problem right there in itself. You're never going to get paid for it. If you don't get paid for it, why are you doing this system? You know, if you're building it for another company, if you're building it internally, it doesn't really matter. It happens all the time, actually. The development department builds something, puts it out there, nobody uses it because nobody really knows what it is, or you know, and it's kind of a waste if you think about it. Part of the acceptance testing inside of a company is to kind of go, well, here guys, it's out here. Actually, we have a new system out for IT students, and I guarantee it, nobody's used it yet. It's a new technical support bug tracking system. If you ever send a message to tech support at itu.edu, you get an automatic response that comes back now. I mean, some of you have done this. Okay, good. So you know that there's this little thing that comes back to you. Now it says, oh, go on to this system. I can't remember what they call this system now. But the system's been sitting out for a couple months already. Some of you people are finally using it or finally figuring out what it is. You don't actually have to send a message to get the instructions for it. You just go out there. There's a forum out there too or something. So I'm going to be doing some faculty support on there soon. I just recently found out that I could. So I'm letting you guys know, hey, there's a system out there. This our department, someone in the department put it together. It's been sent out there, getting dusty. I'll go out there and use it. All right. So now we have phase 6, which is the implementation phase. This is the testing phase. Well, most companies don't do their testing anymore. They have the end users do their testing, which is kind of not so good, but it does, anyway, has some pros and cons to it. Implementation. Implementation phase distributes the system to all of the knowledge workers, makes the system being used, puts the system in place so that the knowledge workers can do it in the course of their job or in the course of using the system, which is kind of like how, you know, that new technical support system is running. Puts it out there so you guys can go to it and file problems that you have. 2 primary implementation activities, write detailed user documentation in this phase. User manuals, wikis, help systems. So we have the user documentation, highlight how to use the system. And then you want to train. The other activity is to train the people, theoretically. In fact, maybe in the student orientation, they should train you on how to use the services at this university. You know, like career services, CPT stuff. I don't know. There's so much stuff that students don't know about. Actually, we're going to have a career fair, too, coming up in November, I think. But long story short, training. Online training, workshop training, or maybe just a memo or something, or a letter you get in the mail, or just maybe an invitation to some orientation. And at the orientation, they have some training for it. So we have different implementation strategies. For your HR system, you could probably do it in parallel. Do a parallel implementation, and then eventually you could take away all the HR stuff. Because if you're building this system to replace some of the not self-service manual HR functionality, then the self-service system could replace that and reduce the head count and maybe save the company some money, which a lot of organizations have actually done. You still have to have HR people, but you don't have to have as many if you have a self-service system put together. So you can choose the right implementation method, and here's some examples. Parallel implementation. So you use both the old and the new system simultaneously. Problem with that is it's hard to get the new people, or hard to get people to go over to the new system. It's in parallel. Some people, the late adopters, will just stay on the old system. They'll never use the new system until they have to. Slower transition, takes longer to implement it. Or you can do the plunge, or it's sometimes called the crossover implementation. You walk in Monday morning, new system is in, old system is gone. Throw you in the water, throw you in the deep end. Here you are, you're forced to use a new system. People will pick it up, people will use it instantly, people will get onto it. You'll find the problems out earlier, things will happen better. Well, the problem is, if there's a huge problem with it, not stable, you're hosed. Shut your doors. If it's a critical system, you can't do that because people won't have a backup if it doesn't work. So if you haven't done good testing on the system, I won't recommend doing that. You want to implement it, get people over there fast, then you do that. Or there we have the pilot implementation. Start with a small group of people and then gradually add more users to it. We piloted out the online classes that we offered this term. So we had 3 or 4 online classes, and they have 30 students in them. And some of you got to take them, some of you didn't. Next term, for spring, we'll have 20 online classes because we'll have full implementation versus this was what's called a pilot. Each department offered 1 course each, and it was an ability to test it out, to kind of give you, to see if the concept works, if students want to take these classes, if things work out. We actually, I don't know if it's been announced yet, but online students can take international students can take 1 online class per term now. So more students will be able to take it. You still have to take, in order to get your CPT, or in order to get your CVIS or CBIP or whatever status, in order to follow the rules correctly, you do have to take traditional style face-to-face classes. But you can supplement with 1 class. One of your classes can be online. So usually the weekend students are really going to like that one, because instead of taking 2 or how many classes they take with CPT? 2? 2. Then you only take 1, and then the other one's online. And not only that, but the online classes are only 8 weeks long. They're accelerated. So you don't have to go 16 weeks in an online class, which is way too long for an online class. Anyway, the format is, this term, the format's been 16 weeks, and it's been extremely long. Next term, it will only 8 weeks long. So it'll be much more contribution you'll have to do during the week, but you don't have to travel to the campus. And during the pilot term, because I'm talking about a pilot example, the pilot term students had to take a final exam on campus. Next term, they won't have to do that either. We just needed to do that to quality control check, make sure that the online experience was equivalent to the on-ground and that students were scoring the same on equivalent exams. So, but that's an example of a pilot that happened live here. So next term, it goes full scale. Next term, we got 20 classes online. Just pick one. So it's not just for the CPT students. I believe the weekday students should be able to take them as well. I don't believe it's going to be restricted to just weekend students. It's everybody. So the weekend students are the ones who are going to appreciate it, because imagine how much you spend in an airline ticket. And how long, I hate those weekend classes as much as you do. How long you sit, 8 hours a day, 2 days straight. It's just, not only does it kill your entire weekend, but I usually end up like exhausted by the end of it. And you guys have to sit for 8 hours. I could stand at least, but it's not good for your health, your mental health, your physical health. Anyway, we also have this thing called a phased implementation. If we're not going to pilot it, we're going to phase it. If we phase it, we're going to implement the new system in pieces and components. People do this with accounting systems all the time. They'll phase their, I shouldn't say accounting, but let's talk about the finance department. They'll phase in some payroll system that they'll use from a bank. And then they get bigger, and then they phase in so they're doing their payroll in-house. Sometimes they'll do their bookkeeping or their accounting outside, and then they bring it in. And then, you know, eventually they bring their tax reporting and everything else inside. Because maybe at the beginning, they don't, you know, at the beginning of their small startup, they don't have, you know, a corporate finance guy, and they don't have a legal attorney, you know, who can do all of their stuff, or a tax accountant or anything like that. But they contract out. That's called phasing, phase implementation. If you phase it, you have to have a really big system you're trying to replace. If we took and, you know, replaced everything on the campus, actually, let's just talk about phasing furniture, because we could phase furniture. We took this one room actually got phased. We took the desks out. Now we have tables in here and we have power. So, and then eventually what they do is go room by room. I think this is the only room that's got the tables though. So I could be wrong. No, a couple more other rooms have tables. No, the one in the back of the auditorium didn't have tables. No. Is this the only room that has tables? I'm lucky. I like the tables. I don't like those. You know, I sat in one of those desks or something, and it was hurting my back. These at least have padding on the backs of those chairs. So. Maintenance. Last but not least, when people go, well, maintenance isn't that like the lonely Maytag repairman commercial? You know, the guy sits around and fixes problems. Yeah, it is. So there's an entire maintenance strategy. You could come up with a maintenance plan, actually, and a lot of companies do. Because what ends up happening is you've got outsourcing going on with your earlier stages of design and development. You bring it in, who's going to maintain it? Hard to say. So you have maintenance contractors. So there's companies that just specialize in software maintenance. They go out to the company and say, hey, we can maintain it. Here's a plan. Here's a process. And they sell you a package. We'll support it for 5 years, 10 years, whatever. And we'll phase it in and phase it out. So you get maintenance people. It's kind of like buying, on your car. I don't know how many people have bought a new car before, or even an old car. You can buy a used car with an extended warranty. It's called a maintenance package. Actually, sometimes I used to call them maintenance packages. Now they call them warranties. Because the maintenance implies that you're going to get some free service with that. You know, like oil changes and stuff. So, preventative maintenance on your vehicle. Tire rotation and stuff. You can do that with software too. That goes in phase number 7. Last but not least, it's saved for last, the maintenance. And then a lot ends up happening between phase 1 and phase 7. And then the people realize, oh, I'm out of money. And, well, you're not going to run out of time, that's for sure. But you're also going to run out of money by the time you get to maintenance. So people are going, oh, we don't need to maintain it. It's kind of like how you buy the expensive car and you go, I'm not going to buy the warranty. I don't have any money for it. I just paid for the car. Okay. So So companies need to plan for the maintenance so they have enough money left over, hopefully, to do something with the maintenance. 2 primary activities: build a help desk. Wouldn't that be nice? Have a help desk for it. Provide environment to support the changes that are going to occur. So the software development lifecycle models only focuses on the project at hand. We have other things and other models and development techniques that we use. This one's called the component-based development. Build component by component. A lot of financial accounting systems are built this way, actually. Component-based development, and by the definition, focuses on building small self-contained blocks of code or components. And that can be reused across a variety of different applications. So a lot of vendors can sell you a component. You use it. It's kind of like PeopleSoft, SAP components and things that companies reuse. So it's component-based implementation strategies. Probably not going to do that with your HR system. You're just going to do a regular old development project with that. Using already developed components to build systems quickly. Building new components is needed. So, in our component-based development methodologies, we have a couple of different things here. We have rapid application development, we have extreme programming, and agile methodologies. Everybody today, this is as boring of a word as user-friendliness. And everyone says, oh, it's agile. Everything's agile. It's like almost like saying everything's user-friendly. It's like means the same thing, actually. It's not that big of a word. People get, oh, we're using an agile methodology. You know what that means? It involves the user early on, keeps the user intact, mixes up the phases. And it's a faster development cycle than it is a waterfall model. Waterfall model, in the beginning, you bring the user in, you say, what do you want? And then the development team goes out, does their work for months on end, customer doesn't see anything. Eventually, a year later, they come back, here's your product. And then, oh, that's not what I wanted. What is that? Major problem with the waterfall model. Then people, okay, let's just do it agile. Agile is supposed to respond faster to change. So customer comes to you. Customer has to actually attend meetings with you. Actually has to be part of the development process. So they're equally involved in the decision making and in the progression of the system. So you're showing them getting feedback, showing them getting feedback. They're more involved than other methodologies, which is the reason why a lot of companies don't like it. Then they got to hire someone to work with this. And the reality is you should have hired someone to work with this. It's like part of what you should be doing. You shouldn't just like trust these guys to do everything for you and then come back and say, what is this after 2 years of time? But long story short, this is the word you're going to hear a lot. This is the one you're going to see. It's a structured methodology that goes through a series of phases, just like waterfall, but it doesn't do them all in order. It mixes them around. You could prototype early on. You could show and you can do prototyping and get requirements from prototyping, or get requirements from analysis, or even get it from design for that matter. So you mix the phases up, you involve the user, and you do it faster, and you have more communication. It's more adapts better to changing environments, changing technology, stuff like that. Then we have this guy here, extreme programming. That's an old word. This is the Facebook methodology. This is those guys did. If you saw that movie, Social something or other, Social, I don't know. There's a whole movie on Facebook and how they Social Network. Yeah, how they had them in a room. If you hadn't seen the movie, they open up a house. So they rent a house, and a bunch of programmers sitting there, and they eat licorice all day, and they live there, and they just program 24 hours a day, 7 days a week for a couple months, and then they produce the first version of Facebook. Extreme. There's no balance in their lives. It's just put them all in there, give them some food. Licorice was the choice. Usually there's a base food that most people eat, like burgers or pizza, candy, beer. Beer's usually involved with that. Some alcohol of some sort. They just stick them in there, and then they just live in there. They're like in an incubation, and they just work constantly for 24 hours a day. They sleep in there too. They have like little bunks that they go and they crash out, and a little shower if they want. They eat, drink, sleep, and program Extreme programming. That's what it is. Nothing much to it. And then we have rapid application development. Rad. You know what that is? It's prototyping. It's not extreme, it's prototyping. You're just going to take and you're going to build it tomorrow. Here it is. It's really not the system. But here it is. Here's your system. This is what you asked for. And then what you're doing is you're going to rapidly put together a prototype. Show it to the customer. Is this what you want? Okay, well, then you go build it. So it takes all the questions out of everything. Usually, sometimes you have evolutionary prototyping that comes from this, and then you have true prototyping. Rapid application is not extreme, and it's not agile, but it's a hybrid. I shouldn't say it's just prototyping. It's a hybrid of prototyping techniques with some rapid pre-generation of the product. Here we go, rapid application development. What is this? Also called rapid prototyping. Here we go. So, emphasizes on extensive user involvement in the rapid evolution of the construction of the working prototype. So the system to accelerate, it's a system to accelerate the system development process without actually doing the process. So you're not going through 7 steps. You're going to say, what do you want? Okay, hold on. Monday I'll come and I'll show you it too. Actually, a lot of people do this who have bad communication skills, because then they can test what they heard. I'm not saying that you have to have bad communication skills to do these techniques, but it's very common among people with poor communication skills because you describe it and then you go do it. And you say, oh, is this what you want? You know, here it is. You draw a picture of it or something. I do it, actually, I do it because I have, I don't know, mediocre, I guess, to average communication. But sometimes I don't understand. And I'll have to draw a picture of it. And I'll say, is this what you're looking for? Is that what you're asking about? And then I can understand what it is, and then we're all on the same page. And then in the meantime, I can build a prototype of it. And I'll come out with, here it is. I do that with apps all the time, actually. I'll just build the GUI on the app. Say, is this what you're looking for? Because that's what I thought I heard you say, but I'm not quite sure if this is what you're asking for. Because sometimes the customer doesn't know what they're asking for either. It's kind of a mystery. So, anyway, prototypes are models. They're not full development systems. And the team continually designs, develops, and tests the components until it's done. Here's the rapid application kind of process where we have this development cycle, building a new software components, and the cycle of designing, development, testing, designing, development, testing. Uses already existing software components sometimes. It doesn't have to. So a lot of people do rapid prototyping in like Visual Basic or HTML. It's usually 4th generation languages with reusable components. Now, a lot of people are going to yell at me in a few minutes when I say this word, but web development has turned into rapid application development through WordPress. You know how many WordPress templates are on the internet? The entire internet is full of WordPress. I call that rapid application development. Okay, that's why people are going to be mad, because it's like, no, WordPress is a programming language, and I say it's a viable solution to our website project. I know, but when you look at it, it looks like a WordPress template or a modified WordPress template. It's all WordPress. It's okay, but it's rapid. That's rapid application development. You didn't build the thing from scratch. You used a framework to do it, and nothing wrong with frameworks. I'm not mocking it. I'm just saying I'm calling it rapid application development. Quick way of getting a design out there using an existing template. Put it out there. It works. Like how a website in a box. Open up the box, install it, put WordPress on your system. Hey, here's your website. Extreme programming breaks the project into tiny phases, and developers cannot continue on to the next phase until they finish the first phase. They sit there and they just work on it constantly. Agile, here we go. A form of extreme programming aims for customer satisfaction through early and continuous delivery of useful software components. Yeah, early delivery, lots of user involvement. And then we have the software architecture, or service-oriented architectures as an approach. So service-oriented architectures, you focus on the development of the use and reuse of the small self-contained blocks of code called services. And you're going to meet the software needs this way, hopefully. And all of the component-based, well, all of them adhere to service-oriented architectures. And then I'm not going to actually talk too much about because we have an entire lecture on this. Service-oriented architectures is not a software development lifecycle model. It's an architecture for the software delivery, for the use of it. Right now, in fact, if you take this concept, which is about 5 years old, make it more modern, looking at cloud services. We're going to have an entire lecture on cloud services. Actually, it's coming up in the next couple weeks here. So I'll save you for that one. All that stuff was in the category of insourcing. We also have self-sourcing, so that was bullet point number 1. But really, that's what you're going to do for the midterm. You're going to look at the insourcing concepts, building it within the organization. Self-sourcing doesn't really have very much to it. It's end-user development. So the IT department, the support people, it's do-it-yourself. Just bring your own software development with you. Do it yourself. Can relieve the specialists of the burden of having developed the smaller systems. A lot of self-sourcing is good for prototyping. You know, if you can get a business person to create a prototype, usually they do it in Excel and spreadsheets, which is good. Because usually they're doing whatever it is they need done professionally. They're doing, and not to say that Excel is not professional, but normally I find that business, from a software person I can say, normally I find business people overuse Excel. They make Excel into an application or to a program, and then they have so much data tied into Excel that they can't get it out. And they can't merge the data from year to year. It's all stuck in single files. And then they want to put it into a database system. So what we do is self-sourcing, they've solved the problem themselves by doing it in Excel. So you take their Excel spreadsheets, you look at what they're doing, and then you build a real system out of it. And then you have a nice looking database that comes out of it from a self-sourcing solution. So it's not all bad, self-sourcing. And I'm not saying that Excel is a bad tool to use either as a business person, but generally I've seen people use Excel for databases. They keep names and addresses and telephone numbers in Excel. And I'm thinking, why don't you just use Microsoft Access for that? But they don't know what a database is. Or I see them putting, you know, years and years and years and years of sales data in Excel. And then they're manually putting it all together for financial reports and stuff. For people that do, like, you know, even accounting, they keep general ledgers in Excel. I'm thinking, why don't you just do an accounting program for that? Like QuickBooks or something, you know? So, long story short, yeah. Self-sourcing approaches, similar to traditional software development life cycles. Big exception is that the design, development, testing, implementation, and replacement by process of prototyping. They're just prototyping is what they're doing. I shouldn't say prototyping. You're coming up with a solution. So prototyping is the process of building models, and in this case, continually refining those models until they become the final system. So usually self-sourcers will start out with that empty Excel spreadsheet, and they start adding stuff to it. And then if you're lucky, they'll add pages to the same workbook, and then you'll have multiple pages of year by year, because then you can do like a 3D reference and get all the pages together. If they keep them in separate files, then they end up having to deal with all the separate information in the long run. So self-sourcing approaches here. You need something changed. You look at it, you analyze it, you implement it, you identify the basic requirements, you develop the initial prototype, you review it, you use it, you maintain it, you start all over again. So it's a kind of a cycle that you're doing, but it's a prototyping process that you're working with. And you never really get past the prototyping stage unless you're really good. Advantages: quick and easy, and anyone can do it. You don't have to wait for the development team to approve a budget or for their time. It improves requirements determination. If you're the one building it and you're the one who needs it, you're the one who's going to put the requirements in there. Your Excel spreadsheet is going to have what you need inside of it. Might not be the best solution, but it's going to have all the information you want. It's going to fix the problem. Also increases the end user participation and sense of ownership. It's hard actually to get people who are stuck with Excel to get them off of Excel. They'll keep the Excel going even while they have a parallel system that they're supposed to use instead. It's kind of like how people don't like to use Salesforce.com. They'll keep Excel spreadsheets and papers and stuff, and then they'll put it into a Salesforce automation tool because they don't either trust the technology, not familiar with the technology, or don't have that sense of ownership. I'm just putting it into that system over there. How do you know where it's going? It's in the system over there. Anyway. Alright, so let's see. Increases speed of system development. Yep, it's faster if you just do it yourself sometimes. Reduces the invisible backlog. Invisible backlog is the list of all the systems that an organization needs to develop but because of the prioritizing of systems development needs, never get funded because of the lack of organizational resources. You know, it's like the checks in the mail. Well, what does that mean? It doesn't mean anything. It doesn't mean the check's in the mail. It just means, I'll get to it when I get to it. So that's what happens usually with these lower priority projects. The company may never actually implement the spreadsheet, so you might as well just do your own spreadsheet, which is how a lot of the self-sourcing actually works. Because it would take too long to wait for the company to actually do it for you. Self-sourcing disadvantages: inadequate end-user expertise, yes, leads to inadequate developed systems, aka the mocking of the Excel spreadsheets used for everything. I've even seen people put Word documents in Excel spreadsheets. So it's very multi-purposed. It's like, well, you know, it's kind of like the do-it-yourselfers at Home Depot that duct tape everything. Those are self-sourcers. I can fix that leaking pipe, no problem, duct tape. Oh, I can fix that chair, no problem, duct tape. Well, now super glue. Super glue took over for a while. You just, if it's broken, just super glue it. Ah, your car's broke. Oh, look at the piece of, oh, just super glue it. Duct tape, super glue. The self-sourcing disadvantage may not necessarily be the appropriate fix for the problem. Lack of organizational focus creates a privatized IT system where they're not doing anything for anybody else anymore because everybody's doing their own thing. Everyone's using the duct tape and the super glue, so the mechanics have nothing to do. They're just private and doing whatever it is that they're doing. Who knows what they're doing at this point? They're working on other systems. Insufficient analysis of design alternatives leads to subpar IT systems. Yeah, word of caution, never duct tape a leaking pipe. It's not a good solution. And if you're going to fix the pipe, use that, because I have actually had this experience. Actually buy the plumber's tape that goes on the threads, because that pipe will continue to leak if you don't do it right. So, and you know, the plumber's tape is pretty cheap. It's like 50 cents for the little roll, but will save you hundreds of dollars in plumbers coming out to go fix it if you actually do it correctly. You know, buy a new piece of piping, buy a new fitting. Anyway, yeah, no, we had that in a house I lived in for years, and my dad actually did it, and I looked at it and went, that's just, you know, and then you had the blankets on top of the duct tape, and then the box, and then the Tupperware underneath to catch the water, and the bucket that you had to replace a couple of days, every couple of, you know, because the pipe was leaking. And then he actually did that. He actually did fix it correctly, but in the meantime, I'm like, wow, that's like not worth it. But you think about all the time and energy you spend on that, you could just call a plumber. But anyway, lack of documentation and external support leads to short-lived systems. Yes, as well. And you put this back to software, your system's not going to hang around long enough. They're all the right tool for the job. That's the other end user problem. End users must have development tools that are easy to use, support multiple platforms, offer low cost of ownership, and support a wide range of data types. It's kind of like the tools that, you know, the Home Depot people have. There are the right tools, but knowing the right tools, you can't teach an end developer how to be a software engineer. So they might not know about the plumber's tape, or they might not know about the fact that duct tape doesn't add water sealant to anything. They make water sealant, though. That doesn't work either. The pressure pops the water sealant off, the rubber water sealant. So. All right, well, I'm looking at the time, and we can talk about prototyping next time, because prototyping is more complicated. It's not, we've covered all of the software development lifecycle methodologies. Prototyping is another form of a methodology, but it's not as formal, and there's many different types. There's evolutionary prototyping, there's prototyping done in testing, in requirements and analysis. So I'll leave you with the software development lifecycle concepts that we've covered so far, and you can start working on the midterm. If you missed the beginning of the course, I went over the midterm, so you can watch the beginning of this video recording and you'll find a midterm explanation. You're building a project, so you make up the requirements, you make up the methodology you're going to use. Apply a methodology. Apply, in fact, the assignment tells you to. Apply some minimal project management in the planning phase in the beginning, but you don't have to use Microsoft Project is rather expensive, actually. You don't have to use that, and you don't have to use any project planning software at all. Just map it out. Just make a paragraph A lot of people actually like to use outlines. You don't have to write it in a paragraph. You can just outline everything. Don't worry about the 3 to 4 page. It's not the limit, it's the minimum. You're probably going to end up with more pages depending upon how you're outlining, how you're putting your words down. No set format, no set requirements. You don't have to use APA, you don't have to use anything. You don't have to research anything, and you don't have to provide references for anything because you're not researching anything. You're turning the internet off when you do this. But download this lecture first before you turn the internet off. Questions now about the midterm or about software development lifecycle models. So I'll leave you with that, and then next week we will talk about prototyping. We'll do prototyping next week.